You send out the link. I'm just asking because Sarah's wondering if she's asking if you're even recording a class or.
I am recording a class, yes.
I know that, but are you
I got Monday's class up on Moodle this morning, so it's all ready to watch. I do not have the technology to live stream and record at the same time.
Ooh, okay.
Because this campus sucks ass at supporting professors. Seriously, I ordered the camera the second week of August, put in a request for it. Nothing. Okay. I bought my own camera. I wasn't willing to shell out a few $1,000s to get the one that I ordered though. So, hey, no worries, I just started. I'm ranting about our lack of IT support on campus, so you didn't miss anything. Okay, let's start off. Let's construct ourselves a tone nets so we can take a closer look at some neo-Riemannian transformations. Thank you. So, somebody remind me, if I start on C, which is what number? 0. Let's build a pitch glass clock just to keep that in our minds, shall we? 0, 1, 2, 3, 4, 5, 6, 8, 9, 10, 11, back to 0, which of course is C. That will be our starting point. Pitch classes, the easiest ones to remember are, of course, our non-flats and non-sharps. C is 0, D is 2. Excellent. E. Good. F. Yes. G. A. Excellent. And B. Sorry, 11. Yes. Good. All right, so I'm starting on C. We'll build our tone nets based on C. Along the horizontal axis, I'm going to go up and down by 3. Yes, we're going to put our minor third smallest interval along the axis here. So 0, 3, 6, 9, 0, because of course it wraps around itself. So I'm just going to stop there. We're going to make a mini tone nets this morning. All right, building up the vertical axis. We're going to go up and down by 4, our major thirds. So 0, 4, 8, 0. And it wraps around itself. And so this wraps around forever. So 3, 6, and a 9, 0, 8, 4, and a 0. And then finally, filling things in, I can either go 3's this way or 4's this way. That's going to give us 4, 7, 10, 10 followed by 1, 8, 11. Now Matthew, 2, and then if we were to, we can also wrap around the diagonal because our circle of fifths lies on this axis. C, G, D, A. I'm going to wrap A, B, I'm going to wrap B, F sharp, which is the same as G flat, I'm going to wrap D flat, A flat, I'm going to wrap E flat, I'm going to wrap B flat, F takes us back to C, back to our C. I had to keep wrapping because I only have a little tiny 2-dimensional representation of what the tone nets is here.
If you go, okay, so going up northwest by southeast, then you're going up by minus second.
Matthew notices along this axis are half steps coming down. Exactly. That was the observation that kicked off my master's thesis. So not everybody picks up on that right away. So yes, there are half steps that way. We'll get there later in the semester. It turns out that if I take a structure and, think of this as infinite, I could have kept writing like forever. And it wraps this way, and it wraps this way, and it wraps diagonal. It ends up creating a structure called a hypertoroid, which is to say a donut. A donut in three-dimensional space actually looks like a donut. Because you can go around the circle of the donut, you can go around that, or you can go around the diagonals. It looks like a donut, which is kind of cool. We won't construct one of those this morning.
Thank you.
We're mostly interested not so much in the theoretical underpinnings of the sentence as we are in its use. So I'm going to go ahead here and okay, fair enough. Show me my desktop then. We're going to open this up. I'm going to cheat. Now that we've constructed our donets and done our review of how to build one, I have one already to use. And I zoom in on it. And there we go. There you go, 03690369, wrapping around forever, 0480, 0480. That axis. This one I actually might be able to get a good ways in our circle of fifths. C, G, D, A, E, B, F sharp, C sharp, which is D flat, A flat. I made it all the way to E flat before I had to wrap it around E flat, B flat, F, wrapping around to C. Circle of fifths doesn't quite fit on our screen well. Why? How many steps do you have to go through before a circle of fifths wraps around? 12. Whereas this way, you only have to go through 1, 2, 3, 4. And this way, you only have to go through 1, 2, 3. So the diagonal axis is much longer than the other axis. All right. Going to look at some common transformations. And Neumann theory, we love our parsimonious voice leading. We love common tones. We love moving everything else by the least amount possible. So we're going to start with some triadic transformations. And we'll start by looking at how we can change C major into other triads. So we'll start off right here. C major, notes of C major in pitch class numbers. 0 for C, 4 for E, 7 for G. Excellent. I'll go ahead and it's right here. 0, 4, 7. And the lines representing, if you think about them, the intervals contained within the triad. It has a minor third, it has a major third, and it has a perfect fifth. So it visually represents what a C major triad looks like. We're right over here are pitches, C, E, and G. We like to do what are called contextual inversions. You'll need to worry about the term so much, as what we're going to do is we're going to keep two notes the same, keep one of the intervals, and we're going to flip the other interval. So, we can name another triad that has two of the same notes as a C major triad.
A.
I heard E minor, I heard
A.
A minor,
Minor, yeah.
yes, absolutely. So we've got two of them already. There's one more. And I'm going to point out what you guys have done. So far, Caleb kept the C and the E and said I could put an A with that C and E. That'd be absolutely right. Matthew said I can keep the E and the G and I can put a B with that instead. So I kept these two the same, I kept these two the same. That means I could also keep
The C and the G.
the C and the G same, which would give us, what would you change to do another triad, major or minor?
I feel like it'd just be
C minor.
Oh.
C minor and C major have two notes in common,
Oh, yes.
the C and the G. Yes. And so, in fact, you guys have now named the three basic triadic relationships to C major. Let's explore them one by one. I'll start with keeping the C and the G the same. And now I'll show you what I mean by the contextual inversion. So let's look at our intervals here. I've got a perfect fifth, right? C to G, perfect fifth. C to E is how far? What type of third? Major, yes. So we have a major third here. And E to G is a minor third. So now what we're going to do is I'm going to keep the perfect fifth the same, and I'm going to flip the other intervals.
Oh.
So I'm going to have the major third on top and the minor third on the bottom, which of course gives us E flat in the middle, and changed it from C major to C minor. If I write this one on the board,
Wouldn't that, yeah, that'd change it, wouldn't it?
it does change it.
For the board.
We're going to write a different one on the board because now I don't have the notes 0, 4, and 7. I still have which notes?
0 and 7.
0 and 7.
But you need a 3 though.
But I need a 3, so I'm going to keep the 0 and the 7. I'm going to flip the 4 to a
So that would be the minor
3.
version of that.
So now that's C minor.
Ooh.
Now, you guys know what this relationship is called. Because if I have C major as a key and I have C minor as a key, the relationship is same do, different key.
It's not relative.
It's not relative, it's parallel.
Parallel, that's right.
Parallel. So this is our first operator, is the parallel operator. I can turn any triad into its parallel major or its parallel minor.
And they're parallel to each other too.
Yeah, and they're just right across the axis there. So this is our P operator. P short for parallel.
Kind of cool.
And you can see it keeps 2 notes in common, 1 note moves by half step. And the parallel of C major is C minor. The parallel of C minor is
C major.
C major. Flips back and forth. All right, let's do another one. Let's start off with our C major again. And all right. I put the major third on the other side there. So this time we're going to keep the major third, and I'm going to flip the other ones. For instance, instead of having the minor third on top, I'm going to have the minor third on bottom. And then instead of having the perfect fifth go up like this, we're going to have it go down like this. So I flipped the chord. When I do that, we get what note?
A.
A.
So it would be 094 instead.
Yeah, we've got the 0 and the 4, we kept those 2, and then I switched from the 7 to the 9 exactly. Right over here. 0 and 4 stays the same. 7 flips over to the
So in this whole system, you just like
9.
to keep things the same, just basically making triangle.
Sorry, a little bit muffled.
So with this whole system, you just keep making triangle and like building off the.
Yeah, and then you watch how they transform from
So
one
the-
triangle to the other.
Yeah. So then, once you become familiarized with it, you can start to recognize like shapes and
Yeah,
see like the
you
different
start recognizing very common patterns.
relationships.
Yeah. Christian.
Well, you said that we can do chord analysis with
Uh-huh.
this, but could you potentially like build kind of a rudimentary structure for a song just using?
You could use this as a compositional method, absolutely. You can even like draw a picture on the tone nets.
Oh, that's kind of cool.
And create a composition out of that
Valley
picture.
and, like,
I do know some people have done that. It's kind of fun.
Draw Mario.
I like it. You're getting all sorts of ideas already, just as we're giving you the very basics of the system. It's very intuitive, isn't it? Yeah. So, what's the relationship between C major and A minor? It's relative. So we call this the relative operator. C major is the relative of A minor, and A minor is the relative of C major. Again, it flips back and forth both ways. And it goes this direction now. And this is our R for relative, yes. So I've got parallel, I've got relative. You can already see I'm missing 1. Which notes am I going to keep in common this time?
4 and 7.
I'm going to keep the 4 and the 7 in common. And then we're going to flip that way. Okay, so let's build our C major one more time, and we'll keep those 2 notes in common. We'll keep that interval in common, and we'll flip it. I didn't really leave myself good space for either way. I can fit it down here. I can. So this time we're going to keep the E and the G the same. Major third in the bottom. Put the perfect fifth out this way. We're going to keep that. I'm going to need to move it down here to fit. We're going to keep the E and the G the same. And we're going to flip it. So instead of the major third attached to the bottom of this structure, we're going to put the major third on top. With again a perfect fit between our outside notes, which changes the note to B. And this is Matt's E minor triad that he observed earlier. Which of course are the notes 4, 7, and 11. And so this one just flips right out to here. So now I have something that flips across that diagonal axis, the perfect fifths. I have something that flips back and forth this way, relative. I have something that flips up and down. And this one, you need a name for because you have not run into this relationship before. This is called, and my apologies, because nobody bothered to translate it into English. They just adopted Hugo Riemann's term back in the day. This is called the Leitone Wechsel. L for short.
Ooh, German advocate.
Oh, German. It's all German to us. Okay, well let's translate. What does Leitone Wechsel mean? It's made up of 3 different parts. Leitone Wechsel. Which one of those 3 parts do you have an idea what it already means? Tone. Tone means what? Tone, yes. We've got a cognate. So that helps. Tone is tone. Okay, what type, let's see if we can kind of pull out some more etymology, common etymology. Which tone would be a Leitone?
A false tone? Or like a light?
You're thinking the pronunciation of lie, like
Yeah.
tone. Look more at the letters. Which tone starts like with L-E? Leading tone.
Oh.
Yeah, the light tone is German for leading tone. You're not going to guess Wechsel, so I'm going to give it to you.
That was my first guess, actually.
Just like Caitlin was sure she could nail your dictation yesterday, and I couldn't find it for her.
I was so upset.
Light tone vexel, leading tone exchange, so called because in the key of C major, I'm trading the tonic for the leading tone. Yeah. You have actually run into this before in a minor context without knowing it.
Are those dominant? No, wait, never mind.
Let's look at this. I'm going to change this from this into solfege. Do, mi, sol. We keep the mi and the sol, and the do changes to
T.
T. Leading tone exchange. Do becomes T. Keep the rest of the chord. You hear that in movie music all the time. Very common progression. All right. Thinking about it from minor, however, let's look at what happens when I go from minor back to major. So I'm not going to think of this now in the terms of major do, mi, sol, ti. I'm going to think of this in the terms of E minor now. So I'm going to call this do, mi, and sol. And we're going to keep the E and the G, which is do and mi. And we're going to switch the B to the C, which changes the sol to lay. Ah, it turns out that when we do that whole, I'm going to change it from a T653 to a T753, it's a light tone vexel. As I change the sol, I change that sol to lay. It's basically a light tone vexel, that sol lay switch that we've been talking about as we do dominant sevenths into diminished sevenths is a sol lay switch. And so that's kind of a light tone vexel concept. And so over here then is our L. And those are our three possible operators that keep two notes in common, P, L, and R. If I were to reorient tone notes, by the way, I could rotate it so that's pointing this way to point it. I just want to do something with this because it makes me happy. I'm going to joink so that the blue lights down. Doing that, it's going to put my R here. And my red is going to flip here. And my parallel. Let's make that look more like an A minor, shall we? A parallel will then be on top. Oh, yes, it would. Neo-Riemannian theory is the triforce of power in music theory. Yes, it is. That makes me happy. Because I rotated it. Has nothing useful to do, but it makes me happy. So, and making people happy during the pandemic is useful, isn't it? Okay, parallel relative light tone vexel. Let's have do some quickly. Somebody give me the major or minor, try it.
I want to say F sharp minor.
F sharp, I heard an F sharp. F sharp major, F sharp minor. F sharp minor. What is the parallel of F sharp minor? F sharp major, yes, we start off with the easy question there. Well, there's, we do the easy questions first. What's the relative of F sharp minor?
Maybe.
A major. What is the Lantone vexil of F sharp minor? The tone nets might help us answer this more quickly.
Yeah, it does.
Let's do a tone nets quickly. Build me an F sharp minor. What are their pitches? F sharp
F
is
sharp.
6. Good, we got 6.
Nine.
9 for the A. And 1 for C sharp. I need a light tone vexil, which is going to go flip across which axis? This one, or this one? The bottom one is going to move up and down, yes. So this then is going to be our light tone vexil. So now 2, 6, and 9 is what you chord. D major. Yeah. So the tone nets can help you if you just sketch it out. You can quickly do these transformations. The tone nets is a lovely tool. You just have to get used to pitch class number system. And the more you use it, the quicker you become at. I know D is 2. F sharp is 6. 9, that's an A. 10, B flat. 9, A. 1, that's a C sharp or D flat. The more you use it, the more you just immediately click those together.
Is there a pattern in thirds when it comes to finding the light tone vexil?
Hmm?
A pattern in thirds, because like when we went from C major to the E minor to find the light tone vexil, we went up a third. but
There's a third relationship there, isn't there?
When we found the one for F sharp, we went down a third. So we
Ah.
went from the major.
Yeah. And so there are median and, as it turns out, what we call chromatic median and double chromatic median relationships built into Nehemiah theory. In fact, that's the term they used to use before we figured out that we could call them P, R, and L. So yes, there's absolutely third relationships here. And there's more because I can chain things together. Let's do some tone nets chains. This is fun. These are single or unary operators. I can do binary operators, which is to say, if I take 2 of these and do 2. So, first of all, what happens if I do 2 parallels? C major, give me a parallel. C minor, give me a parallel. C major. Okay, so if I do 2 of the same operator, it cancels itself out. So my binary operators are going to be combinations of 2 different operators. How many possible combinations can we come up with using 2? Shall we list them out?
Well, relative entirely.
Yeah, I could do a relative followed by a parallel or an RP. Let's see, make sure corner, or say over here. Binary operators. That's the blue is the most visible marker. Not that anyone can read anything on this recording, but so I can do a relative followed by a parallel. Yes. What else could I do?
Parallel and light.
Parallel followed by light tone vexil. Go. What else could I do?
Relative to light and vector.
Relative followed by light tone vexil. What else could I do?
Light and vexil.
I could start with the parallel and then go relative.
And then you can flip the other one.
I could start with the light tone vexil and parallel. I could start with the light tone vexil and relative. As it turns out, it doesn't matter which order you go, because it'll take you a different direction. Let's do some of these. I'll start with our good old C major. All right, let's apply an RP operator to C major. So start, we're going to trace our R first. Here we go, let's right here. And then we're going to apply P to that. 914. There we go. RP. Which took me from C major RP of C major took me to what? 9, 1, and 4.
Then,
A major. Yes, indeed. So as I say, I changed my C, E, and G, and I changed it. You can see this time I kept a single note in common. There's one place where the two triangles touch. On pitch 4, which is E. And then the other notes changed. My C changed to C sharp, and my G changed to A.
So you move up. Oh, I see. I see. Up by half step.
So by half step and up by
Whole step.
full step. Stepwise motion, common tones.
That's cool.
Gives us this sound. Plus it's roots. We again hear that in movie music all the time. All right, let's do another one. So that was RP. How about we reverse it and go P, R. Start with P. Take me to R.
now we're
E flat, G, E flat, takes us to E flat major. So C,
how many particularly matter in this? Like the root?
it kind of starts becoming a question of convenience. What's the easiest way to notate it so that your performers are playing stepwise music as much as possible? And it stops becoming less more flats go down and sharps go up. And it starts to get into more modern notations. So it comes from these transformations. And of course, that sounds like this. Watching our common tones, which one stays the same?
The 7.
7, which is G.
G.
Stays the same. And then E goes down by half step to E flat, and the C goes down by whole step to B flat, and I've got myself a transformation. Cool. You will also hear these particular relationships as being chromatic medians. Medium by thirds, just like these are thirds. Tonic submediant, tonic mediant. We're used to those terms, median above, median below. Also a median below and a median above, but they have shifted chromatically. There's been a half step motion, so we call it chromatic median. All right. Chromatic medians. Let's do PL and LP. Change color. All right, C major, take us to P, but this time instead of going R, we're going to go L. Taking us down to here. I should notate this more over here so it can be seen on camera. All right, so C, if I add PL to it, it gives us what? A flat major. Yep. Look at our common tones. What changes? What stays the same?
C.
C stays the same. E shifts to E flat, and G shifts to A flat. Couple of half steps there. Again, I've got a mediant, and there's been chromatic motion, so this is also a chromatic mediant. LP, of course, is going to take us not shifting down a triangle, it's going to take us shifting
Up.
up a triangle. There's our L, followed by P, giving us which chord?
E major.
E major, good. So C, following an L, P, takes us to E major. Common tones. Which one stays the same? The E does. And then the G shifts to G sharp, and the C shifts by half step to E. Here's C to A flat.
That seems like it's used a lot too.
Yeah, shifting to E major. Also use that. In fact, I can already hear my head that C to the A flat. There's something of the opening to the second movement of the New World Symphony in that sound. A beautiful brass chorale. So literally, I think the tuba plays in the entire symphony. It happens at the beginning of the second movement, it happens at the end of the second movement. And he has to count everything in between. All right, cool. So we've had 4 different chromatic mediants then, as I can shift triangles back and forth here, or I can shift them back and forth along this axis. Chopin used those, didn't he? In his E major prelude, when he modulates from E major to C major, and then he modulates to A flat major, and then he modulates back to E major. I can plot those key relationships very easily on the tone nets. Black. E major, E G sharp, B, modulates to, oh, I put it in the wrong place. I'm gonna not have room to wrap around. I'll put it over here. E major, he modulates to C major, he modulates to A flat major, and he comes back home to E major at the end. And so his key relationships are a chain of P, L, followed by another PL.
This just makes me think about that. Like you could pretty well go anywhere if you wanted to.
There are lots of
There's
possibilities.
lots of ways to get around.
It starts opening up the analysis of all sorts of different ways. How does I get from this chord to this chord?
If you just sit on the piano, I do sometimes just play chords, like, and switch keys all over the place. It can sound really cool. You're just not really going anywhere in particular.
Just not thinking about functional harmony, but thinking about transformational harmony, which, as it turns out, includes functional harmony as a subset, because that's do RL and LR. Let's clear some room so we can see that a little bit more clearly, because everything's getting filled in here. Good, so here I am with C major. Okay, let's make the try. Where's the way? Sad. Can't mind this. All right, let's do an R, L. So from C major, take me to an R.
904.
through 4. L from that is going to flip me down.
The down, yeah.
So there is an RL. What's the chord? F major. Good. My blue again. So C major to F major is an RL, which is to say, C, E, G, keep the common tone, move the other voices by step or half step. E to F, G to
A.
A, and suddenly you know how to voice lead that very well because that's the 2 basic 4-part writing voice leading. And if I go the other way, L followed by R, that takes me from C major to
E.
G major, yes,
Yes.
Oh, yeah,
Well,
dominant, subdominant.
which is dominant and subdominant, yes. Yeah. C, E, G, keep the G the same. Move the others down by step and half step. Just to say we have chromatic medians, which are new and colorful and surprising, but I also have dominant and subdominant, which is to say everything that Ramon knows about theory fits in that little category of neo-Iranian theory. It's a bigger universe we've stepped into. And we only just did 2 things. Now we can do chains of these. Maybe we can chain them around. And I could do them chains of binary operators where I skip from one to the other. I could smooth it out by playing the chords in between. And so we'll play the chords in between, start in C major, go to E minor before we go to E major, go to G sharp minor before going to A flat major, go to C minor before coming back home to C major. Because as it turns out, if you follow binary operators around, it will always take you back to where you started eventually. C major. To E minor. To E major. To G sharp minor. To A flat major. To C minor. To C major. Or the other way. And just shifting colors as I was talking about. All right, let's do a different cycle. Those were P's and L's. Let's do P's and R's.
C major, F sharp major. I think that's-
Oh, you're getting to the fun operators. We'll talk about those on Friday. All right, so we're going to do PRs or RPs. Let's do RPs first. That way my brain will think easier. C major relative to A minor. Parallel. Relative to F sharp minor. Parallel to F sharp major. Which is relative to correct. Go the other way. C major, C minor. E flat major. E flat or D sharp minor. F sharp major. F sharp minor. A major. A minor. Back to C major. All right. Let's do some RLs. You know this one, actually. Oh, that's falling thirds, as it turns out. I could keep going on that one. I could take this one. Right away. G minor. Relative. I have to go through 12 different of those before 12 is different? No, 24. I have to go through 24 chord progressions to do an entire LR chain because it touches on every single possible major and minor triad before it gets back home. The other way, of course, would be going up. It should be going from here to here to here. Oh, wait, I'm going to do that one in minor because I know that one too. Cadence. That word, cadence. Come too far to I'm going to get lucky by that punk. It's going up the LR chain. Yeah. So the Neo-Riemannian operators, turns out, all over the place. My theory of harmonic functionality actually boiled out of tone that stuff. During a Christmas break, I woke up at like 6:30 in the morning, which usually I'm like, go back to sleep, Nathan. What are you doing up at this time of day? That's dumb. But instead, I woke up and I said, "Come back to sleep. Wait, jump up and go draw this on the tone. That's what happens." And suddenly I figured out that these type of things underlie everything when I put in a subtractus model for the work motion. So, Neo-Riemannian theory is cool. It's still a new frontier in music, and we'll look at some other cool operators and possibilities for triadic transformations.